Okay, so first of all, we have to make this function equal to y. So y equals cos x squared. Now I'm going to add my increments. So cos x plus delta x whole squared. And over here we have y plus delta y. I can move this y towards the opposite side of the equation. So we will have cos x plus delta x whole squared minus y. Now I can put the value of y from the very first term which was meant in this question. I can use the identity of cos alpha minus cos alpha. So this is the identity that if we are having cos p minus cos q, this would actually be equal to negative 2 sine p plus q divided by 2 multiplied by sine p minus q divided by 2. So over here we have x plus delta x whole square, it would be my p, and x square would be my q. So I can write minus 2 sine, what is my p? It is x plus delta x whole square plus q, that is actually x square, divided by 2 multiplied by sine p minus q. P is actually x plus delta x whole square minus q. Q is x squared divided by 2. Okay, so now let's continue with our simplification. We can open the whole square formula, x squared plus 2x dot delta x plus delta x whole squared plus x squared, this term right over here, okay, divided by 2 multiplied by sine x squared plus 2x dot delta x plus delta x whole squared minus x squared, okay, divided by 2. So I can see that these terms are being added, x squared plus x squared, this would be 2x squared. These terms are being cancelled, so I can cancel these out. Now what's remaining? This is the final form of the equation after cancelling all of these things. And now we can see that we have a 2 over here, right? And I want to cancel these 2's, but the problem is that we are not having a 2 with this delta x squared, okay? So I have to introduce a 2 because I need to cancel these terms, okay? If I am not cancelling these terms, it would cause a problem for me in the future steps of this question. So I have to remove the 2's right over here, right? This 2 over here. So I can do first of all minus 2 sine, okay? Let's take the 2 common. We have x squared plus x dot delta x plus, let's leave this term for a while, and over here we have 2, right? This was the common term, okay? Right, that's perfect. Multiplied by sine. Okay, let's take the 2 common. We have delta x multiplied by x plus, let's leave this term for a while, okay? And in the bottom we have 2, this thing right over. Okay, now if I'm taking something common, for example, if I have a term 2x squared 4x, we know that 2 is common and x is common, so I'm going to take out 2 and x. What's remaining? X squared plus, we actually divide this term, right? We are dividing 2x squared by the thing which we are taking out common, right? And then we are actually dividing every term which we are taking out common, right? So over here we have 4x divided by 2x. This is the term which we are taking out common, right? So what's happening? 2 is being cancelled and x is cancelled by 1 power. So we have x plus this term is cancelled, 2 cancelled by 2 and x cancelled by x. So what is remaining? X plus 2, right? So this is the final common term in these terms, right? So how am I going to do it over here? We are taking out common from this term, so we have 2x squared plus 2x dot delta x plus delta x squared, right? I'm taking out 2 common, so I'm going to divide 2 by every term present over here, right? So I'm going to divide it by 2, this by 2, this by 2, right? So this is cancelled, this is cancelled. We have x squared plus x dot delta x plus, this would be delta x squared divided by 2, and this is how we take out common from these terms, right? So what is the remaining term? We have delta x squared divided by 2, and also here we have delta x squared divided by 2. So this 2 is cancelled and this 2 is cancelled. Okay, so I hope you get the point. This was actually a rough work. Okay, so we have the final term minus 2 sine x squared plus x dot delta x plus delta x squared divided by 2 multiplied by sine delta x dot x plus delta x squared. And now we have to move towards the fourth step, and that is dividing delta x on both sides of the equation, right? But before doing that, okay, I've done that, but the thing is over here we have delta x, right? And also the delta x is common over here, so I can actually take out delta x common over here. Now why am I doing that? Because, sorry, there was a 2 over here. So I can take out delta x common, and why am I doing that? You will come to know this in a few seconds. So I'm going to take out delta x common. So let's just do this in the second step. Minus 2 sine x squared plus x dot delta x plus delta x squared divided by 2 multiplied by sine. Okay, so we are going to take out delta x common, right? So delta x x plus, okay, so this was squared power, so we have delta x remaining over here divided by 2, and over here we have delta x. Now why did I do that? Actually, this delta x would not be placed over here, it would be placed outside this term because this was being taken out common from the angle, okay? So this was delta x right over here. Now I can cancel these delta x's from this term, okay? So because these are being multiplied, these terms are, all of these terms are being multiplied, so I can take out delta x common over here and I can cancel these terms, okay? So now what would happen, we have minus 2 sine x squared plus x dot delta x plus delta x squared divided by 2 multiplied by sine x plus delta x divided by 2. So I hope you get the point of taking out this delta x common and cancelling for it from the term. This was a thing which was very unique over here, and it needs to be done at this point, because if we do not cancel out delta x at this point, then when we will apply the limit, this would actually be equal to 0 and our function would become undefined. So we have to take out delta x common from any of these terms and then cancel it out from the term which is present in the denominator. But your question would be that why didn't you take out delta x common from this term? Because you can see that delta x is present over here, delta x is present over here, but delta x is not present over here, so I cannot take out delta x common from the first term. So I'm going to use the second term because we have delta x in both of these terms in the second part. Okay, now let's just apply the limit, and we know that in the previous question when we were solving for the sine question that we have a property limit of delta x approaches to 0, sine delta x divided by delta x is actually equal to 1, right? And we are using this property in all of these questions of the trick questions, right? So I can put a limit over here, that's fine. Delta x approaches to 0, delta y divided by delta x would be equal to this negative 2 is a constant, so I can use the limit over here, limit delta x approaches to 0 sine. Now you know what? I'm going to name this function the victim of this question. We are going to put every strain of this question on this term. We are going to multiply this term by x plus delta x divided by 2 and divide this term by x plus delta x divided by 2. Now you would be thinking that why the heck are you doing this? We were literally at the end of the question and now you are doing this thing which is very weird to do. Now you know what, I used the identity over here. We want delta x over here, and in the bottom I also need a delta x so that this identity can be used and it would be 1, right? So we have x plus delta x divided by 2 right over here. This is my angle, right? This is my delta x for this term. So I want a delta x in the denominator. You can see that there is a delta x in the denominator, x plus delta x divided by 2. This term can actually be written as, so you can see that this is the actual term, right? I'm multiplying and dividing this x plus delta x divided by 2 and x plus delta x divided by 2 by this term point over here. So I can write this term in this form, x plus delta x divided by 2, x plus delta x divided by 2. And you can see if I apply the limit over here, these two angles are same, right? This is my delta x and this is my delta x, so this would actually be equal to 1. This is the thing which I'm trying to do over here. Okay, so I hope you get the point. Okay, so let's just apply the limit. Wherever we are having a delta x in this term, I can put a 0 over there. So this would be 0, this whole term is cancelled, this would be 0 and this whole term is cancelled, because 0 divided by any term would actually be equal to 0. So we have sine x squared remaining over here, and over here I told you what would happen. This would actually be equal to 1. And over here we have this term is remaining, right? So we have delta x divided by 2, this would be 0, and we have x remaining. So this is the final derivative, minus 2 sine squared x multiplied by x. This is the final derivative of cos x squared.